you want it. Yeah.
Okay. You don't have to do it now, but yeah, thank you.
Yeah. No, we are hooked in today. Yeah.
How many people were online yesterday?
We had 3 to 4.
Okay. Found out one of them was Frank.
Oh, okay. All right. Well, I think we're supposed to have 6 or 7 that have RSVP that they'll be online, but
Okay.
who knows if they'll actually watch. But yeah. The next meeting is starting now.
Everything that you and Dr. Mark talked about. Yeah.
Okay.
So we got that. It's all happening.
Cool.
Welcome, online people.
Did you hear that one of the people was Frank watching the stream last night?
I think I was told that. All right, and you're logged in. Sweet. You got all the stuff.
Two watching. Are you watching too?
I will be, yeah.
Oh, okay. So we have at least one person.
So, just a reminder, that doesn't work. You got to bring it up so it's toward the front. And it's just not fast enough to do it through live. Sorry. There we go. Just yay. Just not fast enough to do it through live. So when you make adjustments, you're gonna have to do it backwards through this.
Yeah. I just have to remember not to look at the screen when I do it. Look at the actual camera.
Okay, if that works for you.
Yeah.
Yeah. And keep in mind that the live stream is actually, when you look at the live stream, it's actually this is a bit wider than the live stream is.
Okay.
So you want to go back and make sure that this picture actually doesn't cut off something that you want them to see.
Okay.
But this should be hopefully a pretty decent angle.
Yeah. Ooh, that mascara is super cool.
got an objective. It just doesn't want to achieve it. But for now. Okay. So microphone is live. I will give that to you so you can hand it off to Dr. Mock or whoever's kicking this out. No, and we had been told there was one person who was RSVP, so they probably could. I'll pocket that in my charger real quick. Yeah, just unplug it from the wall and from the back of the computer. Then you can, so I'm in this, and actually I've done here and that'll just pull it up. That should work pretty well. But again, there's a Q&A. Someone types it in, you're gonna have to do a question. I figured. Now that you've seen that common us, if someone's microphone is not connected to the chat box.
Oh my God, Ian.
That's their question. Do it. That was mine, of course. And be like, yeah,
I haven't seen you in like 2 months. Good. You seem to have been told.
That's sweet. I mean, this is really, this timetable is a really good one. Audience members, which would be awesome. Yeah. So, oh, I know. Yeah, now it's free flowing, so my life is more. Yes. Yeah. I know. I appreciate it. Like, how can you challenge Andy today? And I'm like, I mean, you have madness. It could have been a hundred. But you were interested in me. Let it be a movie first. You know what to do. I'm going to start setting up. Maybe.
So here you go.
Live. Oh, okay, we're on. All right. Hello, everybody. Thanks for coming. I like to get this thing kicked off. So I'm Kenrick Mock. I'm the interim dean for the College of Engineering. I've got this microphone because we're broadcasting this online to our audience of I'm not sure how many people. And so when we have people come up and there are questions, we'll try to use the microphone. So we are here in the EIB building, the Engineering and Industry building. And with the College of Engineering, we actually have two buildings. We have this building, and then there's the Engineering and Computation building, which is a little jog over that way. So most of the computer science, I guess all of them except for me, are over in the ECB building. So that's where we got offices and classrooms. You'll kind of walk by some of the classrooms in this building. This building has mostly labs and also some faculty offices. So it's a pretty exciting time. The reason we have two buildings is we've had lots of growth. So about 5 years ago, there are maybe 800 or so students in the College of Engineering, and now we have around 1,400 students. So now we got the space, so we're not all crammed into one building. So tonight is for computer science and computer systems engineering to give you an idea about what it's all about. Last night we had mechanical engineering, and if you're interested, tomorrow night we're focusing on geomatics and civil engineering. And then on Thursday, we're focusing on electrical engineering. So if any of those other ones sound interesting to you, or you want to learn more about what is geomatics and what is civil engineering, then come tomorrow. For double E, come on Thursday. So right now is a really good time to be an engineer. There's lots of job demand. So nationwide, and especially here in Alaska, employers aren't able to find enough engineers. Right now, they've had to import engineers from the lower 48. And a lot of employers are telling us that they bring someone up, and after a winter of darkness, they had enough and they leave. And so there's really an effort to grow more engineers right here in Alaska. So if you're interested in staying in Alaska, then this is one way you can do it, through engineering and computer science and computer engineering. And the job prospects are pretty good. So I know Dr. Moore, when we hand it off to him, he's got some more info for you about that. But we do a survey of our graduates when they graduate. And on the survey, 74% of the graduating students already have a job lined up when they graduate. So not bad. The salary ranges are typically $50,000 to $60,000 a year. So that's pretty good for that was more than I was making when I first came out of college. I also wanted to mention that our programs are all accredited. So there's been some news lately about accreditation and UAA. And so all of our Bachelor's of Science degrees are all accredited. Computer science is actually being reaccredited this year. And that's not a bad thing. So I was talking to one person, they thought, oh no, if you're being reaccredited, does that mean you lost accreditation? And that's not the case. Every X number of years, all the programs have to go back through this cycle. So it just happens to be right now, computer science is up for its cycle and it's in good shape. All the other engineering programs, their cycle doesn't come up until 2022 or 2023. All right, so with that little bit of intro, once again, thank you for spending your time with us to learn about computer science and computer engineering. And so I'm going to turn it over to before I turn it over to Dr. Moore, a couple little things. If you're a high school student and you haven't signed in yet, please sign in up at the front so we know you're here. Awesome. And then what kind of the agenda for this evening is, after we give a little bit of presentations about the program and the faculty, we're going to have our Computer Science Club president talk a little bit about the Computer Science Club as well. Then we'll take around 10 minutes for mingling, have some snacks, and then we're going to break you into 4 groups and then send you up a floor and over to the other side of the building where we have some demos and kind of activities to show you. So that's the agenda for the evening. All right, so I'd like to turn it over to Dr. Frank Moore, who is the chair of the Computer Science and Engineering Department.
Welcome, everybody. It's glad for us to be here, for you guys to be with us. Really exciting that you all are interested in computer engineering. I'm trying. The old voice is getting a little tired tonight. So I'll try to talk as loudly as I can. I'm not used to holding a microphone, but there you go. So I brought a few handouts with me that are kind of interesting, and some of them are right down here. You're welcome to come down and pick up a copy after this session is done, or we could pass them around if you'd like. But here's a handout called "The Top Jobs in the U.S. in 2019." And among them are number 1, data scientist. Number 5, project manager. 6, DevOps manager. 8, data engineer. 10, software engineer. 17, security engineer, product engineer, Java software developer, electrical engineer, solutions architect, data architect, applications engineer, quality assurance manager, systems engineer. That is the most in-demand job in the United States right now. Software engineering manager. That's the highest median base salary of any job in the United States right now. Software developer, and software development manager, systems administrator. It goes on and on. These are just the computer science related jobs that are listed in the top jobs list from IEEE, the Institute of Electrical and Electronics Engineers, for 2019. So there's some copies of these floating around. Might want to take a look at that. Here's another group. It's called Indeed, listing the best job prospects in 2019. So you guys want to know, am I going to be able to get a job in computer science? And how good of a job am I going to be able to get in computer science or computer systems engineering? And a number 1 job, according to Indeed for 2019, is machine learning engineer, which I'm really happy about because that's my research area, as well as Dr. Mox and others. So number 1, machine learning engineer. Number 3, full stack developer. You're going to learn what that is if you don't know already, but it's a computer person. Okay. Number 11, robotics engineer. Robotics is really cool. And you can learn about robotics here. Computer vision engineer, number 13. So you can see that about 5 of the top 20, if you have that handout, jobs in the United States, according to Indeed's best jobs of 2019, are computer science and computer engineering related. Now, another set of handouts that are over there on that table describe the 3 programs that we offer in our department. And they are the main one, probably the core one, I guess I could say, not really the main one, but it's the Bachelor of Science in Computer Science. Okay, so with the BS in Computer Science, you're expected to take enough stuff, the things that ABET, the Accreditation Board for Engineering and Technology, want computer scientists to learn. So you have to take some physics. You have to take some math. So a year of calculus, a year of physics. Doesn't have to be the calculus-based physics, but it has to be a year of college physics and some other requirements like that. So it's a little bit math and science heavy, math and physics heavy to be exact. And not everybody wants that who wants to get a degree in computer science and become a computing professional. Some people would rather have the option of taking courses in some other area like business or even an art or a science. So there's the Bachelor of Arts that leaves the room for you to do that. The Bachelor of Arts program does not require a year of calculus, and it doesn't require any physics, but it does require that you specialize in some area of second concentration. So if you want to apply computing to education or to business or some other area, the Bachelor of Arts is a great way to do that and to get the additional training in that second concentration area. Now, not necessarily my favorite, but the 3rd program that we offer in our department is computer systems engineering. So computer systems engineering is what we call it. A lot of the rest of the world just calls it computer engineering. So if you're wondering about that systems word, don't pay no attention to it. Okay, it's like it's not really even there. It's really computer engineering is what it's called everywhere else. So what does a computer engineer learn at UAA? Well, they have to take the calculus. They got to take 3 semesters of calculus. They got to take differential equations. Why? Because all engineers, practically all engineers, have to take those courses. So those are core engineering courses required for accredited engineering programs such as ours. You heard earlier that all 3 of our programs are accredited by the ABET accreditation agency, Accreditation Board of Engineering and Technology. That's the big one internationally for accrediting engineering programs. So in computer systems engineering, then you have those core physics, math, requirements that you get in most of the engineering disciplines. And then you also get some exposure to electrical engineering. Out in the workforce, computer engineers often work very closely with electrical engineers. I know, for example, when I took my entry-level jobs, I worked right next to computer scientists on the one hand and computer engineers like me and electrical engineers all doing basically the same job. So we all worked quite closely together on military simulation, to be exact. I lived in Dayton, Ohio. That's one of the things you get to do there if you live in the Dayton area, right? Patterson Air Force Base is there. So anyway, the idea though is that we've got 3 great programs. We've got programs that consistently produce students who rank in the 80th percentile on average, taking a national standardized test that are given to graduates across the United States. Very many big name universities with football programs and basketball teams that you probably watch on television don't rank anywhere near that high in the same rating. Okay? So you can come to UAA, and not only are you going to get an in-state tuition as Alaska residents, but you're going to get a darn good education. 80th percentile graduates, that's really good. Okay? Better than 4 out of 5. And it's right here in Anchorage. Okay, so I think that I think we have a great program here to offer you at any of those 3 programs would be perfectly good. Now in Alaska, the BA, the BS in computer science, not a lot of difference there. If you wanted to work on with engineering firms outside of Alaska, you might want to lean more towards the BS. Or if you really want to do engineering as a career, lean even further towards engineering and get the BSE degree. But they're pretty close related, and a lot of our graduates compete for the same jobs from all 3 of those programs. So at this point, I'm really encouraging you to consider one of those 3. Any one of them will do you very well. And now I'd like to introduce some of the faculty that are here with us tonight. First of all, from Carnegie Mellon University, Sean Butler.
Hey, good evening, everybody. My name is Sean Butler. I graduated from Carnegie Mellon University in Pittsburgh with a PhD in computer science. And before I did that, I spent 20 years in the military building software systems for the Department of Defense. I retired as a lieutenant colonel. So there's still life after the military. I've had a really great time building software all my life. My focus, I teach here at the university. I teach software engineering, where we do real world applications. I find people that need projects to be done, and then we go support those clients, those people, and we run it like we've got a real project, like we're accountable for getting something done, not just kind of working at it, teasing it, and going, oh, well, we got as far as we could. So I really believe that my job is to make sure you guys are ready for the workforce and that you have the skills necessary to succeed and compete against other schools for the same jobs. That's my passion here at UAA. And so I have a lot of students that work with me on special projects that we hire. So if you're a student that needs a part-time job, sometimes we have opportunities here at UAA for you to work part-time, work with some of the professors, work with me, and develop some of those skills and build your resume. I also teach computer security. I teach computer networks. I teach, this semester I'm teaching Introduction to Computers. So I teach a lot of different courses. And I love my students. I can't get to see them enough. And I think that's most of us here at UAA. We really like working with students. So, but again, my passion is to make sure that you get the experience and the skills necessary to compete out there in the real world. So is that all I need? Okay.
Next, I'd like to introduce Frank Whitmer.
Yeah, hi, I'm Frank Whitmer. I got my undergraduate degree from Tufts University and graduate degrees from CU Boulder in Colorado. I do a wide range of teaching and research here. So I teach Java, Intro to Java, and Python, data structures and algorithms. Also an upper division geospatial programming class. So I got degrees in geography and computer science and math. And I really love thinking about problems spatially and thinking about spatial relationships, complex relationships over space and time. And so I've done research in violent conflict in sub-Saharan Africa and Afghanistan and Bosnia. And then more local research projects that I'm working on are things like coastal erosion. So looking at coastal erosion over space and time, which of course is a big issue for many communities in Alaska. Also looking at invasive species like aquatic Alodia, and also some tick habitat modeling for Alaska as well. So that's it.
We also have Seb Newbar from MIT.
Hi, my name is Sebastian Newmer. I've been at UAA about a year and a half. In 2013, I got my PhD in computer science and electrical engineering from MIT. And my focus there, I was researching the effect of natural disasters and large-scale geographical impacts on network connectivity. Then for the next 4 years or so, I worked at MIT Lincoln Laboratory, where I was researching sort of cybermetrics. So how do you measure the security of a computer network? And during that time, I became really interested in Bitcoin and analyzing the security of the Bitcoin network. And so when I came to UAA, it was pretty awesome because one of the classes, I got to create an elective class. And so I created a class on Bitcoin and cryptocurrencies, which I taught last fall. And I was really excited to do that. And so beyond that, I'm teaching intro to programming, and I also am teaching digital circuit design. I have a couple demos of stuff you might create in the class that you'll see later. Some of the other research I'm doing now, I'm continuing some of that line of thinking of analyzing network connectivity, but I'm doing Alaska-specific studies. So what happens if there was a large earthquake in Alaska? How will that affect communication network or the oil pipelines and stuff like that? But I'm really excited about being at UAA, and thank you.
So I think, is Dr. Mock around? Yeah, there is. Oh, maybe, or we could take the break.
Okay. All right. So I actually would like our CS Club president, Elijah Wog, to come up and just say a little bit about the CS Club and being a student.
So I'm not used to holding a mic, so I might get a little nervous. But so I'm the president of the CS Club, as you said. There's a few of us actually here. So we basically do community-based projects and try to help fix community problems with software. In addition to that, we also try to help students do better in the program. So we teach a number of topics that the program itself might not have. So we did like the CS department as what? Yeah, so the CS department as a whole does not teach a MATLAB class. So we taught it because we thought it'd be something interesting that students might like. And we've also done a security one. We've done a number of other classes. Yeah, we did one on interviewing. Another thing it's just like a cool program too, to meet with other students and kind of have a place to hang out. And the only thing I was going to say, in addition to being on the club thing, is you guys are probably getting hit with a lot of information from teachers, and some of the stuff that they're talking about you may not understand. There's about 6 of us here that are actually in the CS program. So if you have any questions throughout the night and you want to know what it's like to actually go to school here, we're more than welcome to talk to you. So, and we also have a presentation upstairs that we're working on.
All right. Thank you. I had one thing I forgot to say about our students that graduate. So, I mentioned they're going on to get some pretty awesome jobs. I just like give a couple examples. So we have students that have gone on to work at NASA, some students working at Google. Actually, one of the people that's working at Google is working on self-driving cars. So basically, he went to work for Waymo, which got bought by Google. And he's actually giving a talk here on April 18. So if you listen for that, it'll be over in the Wendy Williamson. Let's see, we have a couple students doing game development. I would say that's not the most common career path, but there are some that are doing video games. Microsoft, IBM, Intel, and then local companies as well. So all sorts of job opportunities to work on some really fun, exciting things. Okay, so what I like to do is if anyone has questions, I'm in the group setting, you can ask them for any of us. And oh, we have a robotics club too, and so you're going to get a tour of the robotics lab upstairs. So if you have any questions, we can answer them now, and then have our little mingle break before we get the tours. So questions for any faculty or students or clubs? Yeah. So depending on which test you have, I believe it counts for the first for Calc 1. Do you know if AP you can do which one? You do A, B, and BC, right? So I think BC does count for Calc 2. I have to look at the chart, but there is a chart where you match them up. There's a lot of you can correct me. Yep. Yep. Thank you. Yep. All right. Other questions? You got an online question? Yep. Okay. You got another one? Okay. Yeah. So the last question was about the AP test. What scores would count for calculus? Other questions? Okay, so you'll get a chance to ask when we go on the tours. So let's take a little 10-minute break where you can have some snacks and chat with any of the clubs in the back or faculty up here. And after 10 minutes, we'll yell and break you up into 4 groups and then cycle you through these demos.
This is a little bit different in the sense there is no program running. You're actually just programming, like in hardware, creating out and orienting.
So did you click on it?
Oh, I see. And so you're like building and an OR gates, pulling them together to build one complicated. Yeah, cool. And so this
Are
is
you in
like the
Google
same
Hangouts?
thing, except for this is FPGA, so you can like basically do all soldering. But the problem with soldering, when you create something big, it's like sort of
Okay, so in the lower right-hand corner,
so what you start doing is
there should be a white reticle around you or one of the participants, and you can click on
the
that
signal
one
to
to
be
make it
together,
go
and
right.
so like I'm trying to say that's how it's built, and then you like this gets compiled and you describe that hardware and on this chip. It's not a microprocessor; it's actually like this and an OR gates getting soldered together when you just sort of flash that.
Hello, yeah, I'm just waiting for it to click over. Perfect, thank you so much, that worked.
So it'd be a challenge. It's tricky. Like I played around with this for a couple. It's getting things to work correctly. And some of the letters like W don't fit on the sentence. Like seriously, if the user imagination, some weird character pops up, you might have to figure out, oh, it's a W or a Z or something.
No, I'm not. We just started. So.
And Seb, just so you know, you also have the virtual people in this group.
Oh,
yes.
So just thought you'd like to know that.
For the virtual people, I was just describing how in 342 we do this digital. We create digital circuits, but instead of like wiring together and an OR gates with solder or a breadboard, we like do it on FPGAs. So you do this with hardware description languages, and so there's this FPGA you flash the chip. The chip doesn't contain like a microprocessor, like an Intel chip or an AMD chip. It's just kind of a blank chip. You could put a microprocessor on it, or you could put a Morse code decoder on it. You put whatever you want on it. Cool. Yeah, that's okay.
Okay, yeah, that was
SOS is good because it's just triple tap and then 3 long taps. It's a little easier.
I think they did that on purpose.
Yeah, for like the Titanic.
Communications, they wanted, because those, before they did the actual signals, they needed lights. And the lights had to be simple, especially because they was like, all right, what are the codes? They determined what the codes were, what they were in the simple letters. So when SOS were like, well, okay, let's just make this the simplest one possible, because because you have to convey a message in simplest terms using acronyms.
Oh, so I didn't know what Morse code was then invented like prior to digital.
Yeah, it was way before digital age, because you had to do it with lights. They would do it flat.
Yeah, that makes a lot of sense.
So, and if your ship is about to go down and you're just offshore and then people are looking, I'm like, hey, you can see the light, you can flash your light, SOS, and they're going to send boats out. So I learned that from my dad, and like his brother was a fisherman, and his brother liked that. So.
And I know for like
I never actually learned Morse code.
So this is the first year I did this, so I'm only just coming. I can't. I have to stare at that chart a long time and practice before I'm able to.
I've never done Morse code myself. I just learned why they did Morse code and why it was such a simple system.
And one of the cool things is that the common letters are shorter, so E is just a dot. So it's less common to Q. It's like 4 characters. So
yeah, like X is 4 characters, Z is 4 characters, Y is 4 characters, J is 4 characters, Q, F, C, B, D. But like S and T is 1, S is 3, so, and O is 3. But you have to be like, you have to convey a very, very simple message.
Like the old Atari 2600.
Sandwich had to know those acronyms
yeah.
to determine the decision to make. That's
it's
why
double coded.
Yeah.
Can't put any English on it.
No English.
Being able to get a word is
This game will go on forever.
It came in with SOS. I think I saw that. Took me 5 or 6 tries.
Got a
So,
heated pong match going on.
Oh, no.
This is an ARM processor.
Okay.
Like
You might end up winning at this point.
This is like a very simple one. But what we do in the last lab in this class is, since this chip can contain any digital logic, we actually put the ARM processor on the chip, and then it can start running programs. But it can be anything that you want. So that's what's so cool about FPGAs. It's completely like fabric. It's like that before you start, before you solder anything on.
Cool. Good demo there.
And so if we sort of go like a level up in complexity and come over here, so from Morse code, we can do stuff with the VGA port. So here's the code. So VGA signal, does a scan line like the old CRT tube to have like an electron gun that says, okay, voltage high here for this pixel. And then when it got to the next pixel, do voltage low. And that's how it sort of drew the picture to the screen. So the VGA works by sort of going across like this. And then there's these like active and inactive areas. So you have these synchronizing pulses. And so you can program that sort of logic into this chip. And you can actually draw the VGA port. And here's what that code might look like. And so you can drive that VGA port and you have all the internal logic, but instead of doing Morse code, you can implement a pawn game. So you just create like some internal registers or like basically counters, and you can have a ball that moves around. And so I have rotary decoders here. So if you press the center button to reset, you can actually, this is pawn, but what's cool about it is that it's entirely in hardware. At no point did I write a program that says how pawn works. There's no microcontroller there. This is all happening synchronously. So feel free to like play each other. I think you go up to 4, and the score is kept on the LEDs there. The winning side flashes.
What's neat for me understanding this is that we went from having a giant box that size to be able to just do this, to be able to do that.
I'm a pro.
Yeah. Just the evolution of technology.
Yeah, it's
over the last
I don't think I actually
since since like right before World War II,
Yeah,
right after World War One.
It's pretty crazy.
Yeah,
and it's, I mean, we're getting, they say like Moore's law is slowing down a little bit, but even on mobile, like I know each cell phone every couple of years.
I mean, I can't remember what the company was, but they just developed, and they're going to be putting out their quantum computers, which was they went from 2,000 to 5,000. That's something I would like to get into is quantum computing, but I got to start somewhere.
Yeah.
And I haven't really done anything outside of, most I got to doing anything like this was I have a Associates of Arts in Digital Video Production for a school that no longer exists. So.
Yeah, we build up like in this program. We start there's the course before this one. We do like the breadboard and an OR gate. So we just start like from the gate level, and we kind of build it up, and then
I'd be starting way from the bottom because I'm pretty sure after I take my math test, I'm gonna have to. It's gonna be probably a full semester of math classes before I can. It's been over a decade since I've done that. No, I'm 28. I'm going into this program way because everybody here is like a decade younger than me. So.
All right, can we show that off here? The crypto candy.
Sure. So this one's a little bit different. So I'm into one of my hobbies is Bitcoin. Before I came here, so I was pretty enthused to be able to.
There we go. We got you.
Remote. So one of my hobbies is Bitcoin, and so I was super pumped to be able to teach a Bitcoin course here. Now, a lot of people have heard about Bitcoin. It was popular a year ago with the prices, but I'm a lot less interested in the price of Bitcoin. There's a lot of cool math behind Bitcoin. And so there's a lot of, when you learn about Bitcoin, you have to learn about things like Poisson processes and markup chains. So that's in these Poisson process markup chains, they're useful not just for Bitcoin, for understanding Bitcoin, but they're useful for understanding other natural processes. So the stuff I'm like teaching the class is useful beyond Bitcoin. So it's really, I'm teaching about Bitcoin, but I'm teaching stuff about Bitcoin that's going to be useful other places as well. But what's maybe less useful is this demo, which is just gives candy if you pay it Bitcoin. And so Bitcoin, you have to send Bitcoin to a Bitcoin address. And so this QR code here encodes a Bitcoin address. And so if you want, you can take some Bitcoin. So this is a paper wallet, and you can go and get a Bitcoin wallet, take the Bitcoin from this piece of paper, put it on your phone, and then send it here. And this machine will then give you candy. And so I already have Bitcoin on my phone, so I'll just show you how this would work real quick. So I'm going to, this is my Bitcoin wallet. I'm going to say send, and I'm going to scan a QR code, and I'm going to scan this QR code right here, and it says candy's 5 cents, so I'm going to send it 5 cents. Hit next, and if someone wants to catch the candy, it's going to come flying out of there. So slide to send.
It's gonna rocket out of there.
So I just sent it. Okay, I just broadcast it.
Whoa! More than one.
And so this device like just looks at the Bitcoin blockchain, sees when this address receives payment, and then dispenses candy.
I was fully expecting that to come out like an airsoft gun.
Very cool. Thank you.
And so we can even, and what's cool about this, now one drawback or maybe thing that's missing. The point, so what's interesting about this is if I was a candy competitor, I could look at this Bitcoin address and I can pull it up online. My computer would. And I can see, oh, this is this Bitcoin address. And in Bitcoin, the ledger is public. So if I know my competitor's sort of payment address, I can look at it and say, you can see right here that, oh, my competitors received, total received $1.01. And so that's a drawback about Bitcoin in terms of it being used as sort of in certain contexts, is that it's not as anonymous as people think. Like everything's public. So if you know someone's payment address, you can know who paid them, when, the amounts, and everything like that.
Oh.
But I would
It's not as stable as people think it is.
Yeah, definitely unstable in the price. So if you want, you can, each of these is only 5 cents in Bitcoin. So you can take out a Bitcoin wallet, try to get it.
All right, thank you.
You're just now live streaming. Okay. Okay, so I've been with the club for about 2 years roughly, and I think one of the best things about it is not just the stuff that you learn, but the communication skills that you gain just by working with other people of different disciplines. And one other thing, I don't say this because I study computer science, but I want to stress to all of you that no matter what kind of engineering discipline you pick, learn to code in some aspect, because that's where the future is going. Is nearly everything's getting autonomized. So, because I know a good handful of, say, mechanical engineers, even some other science majors who minor in computer science, or at least learn programming on their own because they realize that how much more valuable that skill is becoming.
Right, so while you guys are talking, give your presentations, just pass the mic around. Because people who are listening on a live stream, they can't hear unless you're talking into the mic. So, and then I'll just try to hold that up to the speakers during the video.
Where's this being streamed?
On YouTube.
Really?
Yeah, we have quite a few online viewers right now. I think we have like 6 or something.
It's a lot.
Yeah. But yeah, good presentation, you guys. You're doing great.
UAA Robotics is proud to submit our system acceptance for.
All right, coming in, find anywhere you like. Just make sure you. You guys in?
Does the speaker also come out of there, or is it just these?
Just
Okay, you're talking first before you play the video.
Yes.
Okay.
So it's on?
Yeah,
Okay. Okay. Hey everyone. We are UAA Robotics. We are a student club here at UAA. What we do is we build a rover. Right now, our rover is at right there. Number 2. We build it to go to the URC competition. That's the University Rover Competition. It's an interactive competition where teams bring their rovers. Right. Yeah. Where teams bring their rovers to compete. So in the URC, they set out tasks, specific tasks for the teams, and the teams have to accomplish those tasks using the rovers. So we bring our rovers, we compete, and then you're scored on how well you do in each task, and this team with the most points wins. This is our first year going to competition. We are very excited, and that is because we made it past the SAR checkpoint. The SAR is a system assessment review. That is a competitive milestone for the URC. That is when they value and decide who's going, who's not. It's the final cutoff point. Now I'd just like to show you our SAR to give you an idea of the robot and a little bit more about ourselves and the competition.
UAA Robotics is proud to submit our system acceptance review video for consideration by the University Rover Challenge Judges Panel. Entering our 3rd year with support from UAA and many professional organizations, our team of over 30 students chose to iterate upon and optimize last year's design. Introducing Iceberg 3. UAA Robotics divided into teams dedicated to each rover subsystem: mechanical, electrical, software, science, project management. We developed a Gantt chart and task list based on chapter requirements and available resources. By utilizing FEA on mechanical structures, 3D printing, and industrial machining equipment, we rapidly prototyped and optimized new design features. Supplies were purchased, built, troubleshot, and tested systems in development.
Chassis and suspension designs are centered on the extreme retrieval task. Our 4-wheel independent suspension system designed to traverse any terrain including the leader. By utilizing a bulkhead design stiffened with steel rods, we created a small, light, and sturdy chassis. Coupled with our 400-watt brushless DC hub motors, the rover has a low center of gravity and impressive agility.
The rover runs on one 720-watt-hour lithium-ion battery, providing ample power for each competition task. 5 cameras facing various directions to give drivers sufficient visibility at all times. These provide multiple close-ups of the end effector and wide-angle views of the arm and rover. The rover uses a set of 900 MHz ubiquity radios to carry multiple video streams as well as rover commands, allowing maximum propagation through obstacles. A pair of 5 dBi dipole antennas are mounted high on the rover, while the base station uses a 120-degree directional antenna with a 13-decibel gain.
The base station runs a custom graphical application built with WX Python for viewing rover camera streams and monitoring and controlling the rover. It features a navigation system to display the position of the rover in real time from transmitted GPS coordinates and a configurable control system, enabling operation of the rover with a pair of gamepad controllers. We focused on improving our computer vision and navigation software for the autonomous traversal mission. During navigation, the rover uses an onboard GPS and accelerometer magnetometer to precisely determine its position and orientation. OpenCV analyzes the image and depth data from a stereoscopic camera to detect obstacles and hazardous terrain and identify competition markers. Our pathfinding system uses a record of encountered obstacles to calculate the most direct path to
arm design drew inspiration from a number of industrial sources. The shoulder is powered by a 200-pound linear actuator, minimizing any moment forces in the upper arm. The elbow uses a 30-to-1 warm gear transmission that provides smooth, predictable motion and over 100 pound-feet of available torque. This design allows the forearm to be offset from the upper arm to gain 360 degrees of freedom. We elected to use a warm gear on the wrist along with a unique end effector design that is able to rotate continuously without the use of slip rings.
The end effector utilizes a gripper and a screwdriver system to accomplish the extreme retrieval and equipment servicing tasks. 3 DC motors and a linear actuator provide a clamping force of 13 pound-feet in a range of 2.5 inches with precision control of 900ths of an inch. Paired with the robotic arm, the end effector has a 5-axis range of motion. The main axis is controlled via a worm drive gearbox, minimizing power draw. A 3D printed enclosure prevents dust from entering the gearbox and belt drive systems. The replaceable pads on the gripper are designed for versatility, allowing the rover to grip items, enter commands on the keyboard, and operate a joystick. Both Phillips head and Allen key screwdrivers are mounted to the end effector and operated by the same motor to save weight. 2 cameras provide first-person views of the jaws and screwdriver attachments, with 3 laser pointers to aid in operator control.
The science plan encompasses a combined approach that includes visual observations, an array of sensors, and wet lab chemistry to identify signs of life. A camera scans the area for the presence of animals, metabolic waste, traps, microbial mats, iron staining on surfaces due to microbial metabolic activities, and fossils. Rocks and minerals are observed for signs of endolithic organisms. Soil samples are analyzed with a variety of sensors, including spectroscopy and gas detection, and added to aluminum mixture to observe luminescence levels to determine the presence of oxidizers, including hemoglobin, protein, urine, feces, copper, or iron. The commercial off-the-shelf D&EZ Power Soil Kit consists of 6 different solutions that purify the soil samples. Then it is tested using a nanodrop 1000 spectrophotometer to deliver a reading of DNA concentration, DNA purity, and nucleic acid purity.
This concludes our 2019 URC SAR submittal. We appreciate your consideration and look forward to seeing you at the Mars Desert Research Station.
All right, that was our SAR. Stop it. As it said, we're broken up into 4 teams: mechanical, electrical, computer science, and science. Those 4 teams have specific tasks. For mechanical, we build the mechanical parts of the rover. So that's all the structural bits, the arm, the chassis, the suspension, everything. It either goes on or everything that moves. We have science, which handles the planning, the testing, the science testing, and researches Mars and researches the results we expect, so we can be informed when we get those results. And then electrical, they design the electrical systems, all the boards, all the wiring, all the power, make sure there's wired correctly, make sure all the electrical systems put together correctly. Now, pure science, which I'll let.
Hey, so my name is Jacobo. I'm on the computer science team of the robotics club, and what we do is work on all the programming for making the rover drive, move its arms, do everything it does, basically. And the things we're focusing most on are the autonomous attributes of the rover, meaning getting the rover to do its tasks on its own, hence the name autonomous. And also, like you saw in the video, of the graphical user interface, the blue screen with the camera feed of the rover going on. That's the part I work on, the base station, and we're using Python to configure all of that. So the camera streams from the rover onto the laptop that program is on. And as far as what the teams do, everyone collaborates together in a sense. So computer science works very closely with the electrical team as well, and we don't have any members of them here tonight, but there's collaboration amongst us as much as there is every other group: mechanical science, computer science, and electrical.
Yeah, thank you. He's right. We all collaborate. So computer science is electrical to make sure they know how to program the electrical components. For example, if they need to use Python on the board that only can probably be recorded in Python, or they should know the language on a different board. Then, of course, we there work with mechanical to know how how things move, to know maybe mechanical knows a bit needs to move at a certain speed, or to know how fast things can move. So they'll have to work together, which is a great benefit of the club. It mimics the real world in the sense of engineers from different disciplines have to work together to produce one product, one vision. We are a club at UAA, multidisciplinary club. Some questions that have come up that I think are good to answer now are: anyone's welcome. All engineers, all majors. We have some biology and chemistry majors on the team this semester for specifically science. Business majors can come in and help us fundraise and help us with outreach, which are absolutely things engineers would like help with. So we welcome everyone. There's no fee to join. Simply come in and start helping, and we'll welcome you. And you can join the club any time of the year. We always welcome new members. With that, are there any other questions? Okay, so for me, I've learned a lot. It's been great. I've learned a lot about mechanical stuff. I've learned a lot about most notably though about other stuff, electrical and computer science stuff. Like now I know a little bit more about motors. Now I know that motors are controlled by motor controllers, and you have to have a motor controller that connects directly to the motor, before having a board. So a controller board connects to the motor controller, which connects to the motor. I know a little bit more about programming. I know that Python's a very useful, versatile language. I know that for the control boards we use Python. So I've learned a lot. I've learned most notably about outside my discipline, which is awesome. And also, it looks great on your resume. I'm actually graduating this semester, so I'm looking for a job, and it's great to have my resume that I'm a leader in a student club. Employers want to see that. They want to see that you're doing more and that you're leading at your school. What about you?
So I've been part of the club for about 2 years, and my favorite part is probably gaining knowledge beyond the classroom. And sure, you can get a lot of that on your own on the internet, but when you put it into action in a real work environment, you learn from your peers. You learn how to teach people who don't know what you know. And the most important other aspect you can get out of this is learning how to communicate with others. Like I said earlier, with how all of the teams collaborate, because the most important skill in any job, besides the skill of the job that you're already doing, is being able to communicate with others properly. So I've learned a lot about that, and it goes pretty smoothly. Yeah.
You said you're working on software for this. For the rover.
Yeah.
Thank you. Sorry about that. For the rover, you said you're developing the software? And you're trying to make it autonomous? Are you actually trying to develop an AI for this rover with your team?
We could use AI, but the path we're focusing on mainly is algorithms that already exist to.
So it's algorithms that already exist is simpler than trying to do AI.
It goes both ways. There's algorithms for AI, because AI is just a lot of if this then this, and goes further if this then this. So, but in some cases it can be simpler than AI, and it could go the other way around. It just depends on how complex of the project it is that we need to do. And one might call for algorithms more or AI more. So we're using algorithms mainly for the GPS tracking and the autonomous parts of it. And to answer your question, anyone else?
And for a few more minutes, I can talk about the lab. So this is our lab. It's actually a shared lab space. You share it with the FRC team. The FRC team is a high school competition team. It's also a robotic competition team, but it's high school. You can see some of their stuff, some of the rovers over there. You also directly under the tables there bots behind you two. We have, so that's a lot of their stuff's over there. We share the space, and then of course we have our rover, a lot of our tools over here. We have a big old toolbox of a lot of tools. I'm not sure. Oh, okay. 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 Our whole toolbox of tools. We have screws and nuts. We have electrical stuff over there. We have actually a whole cabinet of resistors, capacitors, transistors, a lot of microchips, controlling boards. We have a nifty air tube system. Yeah, so basically, we're equipped to build and test and build and yeah, test the robot and build in here. Develop, exactly. Do what we gotta do. Any questions? Okay. Vicky, are we? Yeah. Okay. But okay. So shared space was also realistic to a real work environment. Some space and all spaces are shared. You have to work with others. Make sure there's an inventory system. Make sure you're taking care of your tools. Nothing's misplaced or lost. So that's also a realistic aspect of working here, of being active in the club that mimics. Yes, that mimics working in an actual workplace.
How many of your activities are faculty driven, and how many do you get to decide that you?
Basically, it's all us, which is awesome. We pick the competition, we pick the URC. We pick what fundraising activities we want to do.
If you want to
We
wrap up
decide,
your
who to
experience,
approach, how much money
thank
to
you
ask
all for
and all
coming.
that. So it's basically
Okay.
which is awesome. So that is our cue.
Super.
Thank you all for your time. Go and drive 4-wheelers.
Unless we need to be over there.
You're good there. How many are there's just 3. All right, you are in for a treat. Okay, so let me. No, this is not fun and games. This is serious research. All right, so here I've got these information sheets. All right, so again, my name is Frank Whitmer, and this is one of the research projects that I've been involved with here at UAA. And it's an NSF, so a National Science Foundation funded project, part of this EPSCoR program, which has multiple components to it statewide. And so this one was focused on South Central Alaska. And of course, salmon are super important to the state of Alaska and the Kenai Peninsula and Kenai watershed in particular. And so this research project is designed to study what the possible effects of different scenarios are on the future. And so you can see here from this table that we've got various climate change possible outcomes in the future, so ranging from no change from the current climate to large increases in temperature, moderate increases in temperature. We also have varying oceanic conditions from colder ocean temps or hard to predict conditions. Economic development, we can have big increases in residential housing and industrial development, changes in population growth depending on migration and population changes. And then also looking at how the fisheries are managed. So we've got, of course, competing interests with sport fishing and commercial fishing and personal use fishing. And so these 5 scenarios were developed through hours and hours of meetings with stakeholders, people engaged and interested
in the future of salmon and the Kenai River. And so from that, we've got these 5 different scenarios. We've got a retirement paradise, an industrial boom, a fishing capital, no more sockeye, and sort of a back to basics. And we can see each one of these has different components, and these are all designed to create these 5 different plausible future scenarios. And of course, you know, if you're really interested, you can read all about it with all this text. And of course, most people think, oh, maybe if you're interested, you read about it. But the idea here is to be able to say, well, how can we convey what these changes might look like in the future easily and intuitively to people? And so that's where the idea of creating this virtual world immersive experience came about. And it's sort of in beta stage now. It's working pretty well, but it's not totally polished and final. You know, the idea is you can put on the headset and then, you know, basically click on, you know, retirement paradise or industrial boom, and then be transported into this futuristic world and say, oh, okay, this is what it might look like. And that might affect then your decisions for how you want to act today. You know, some of these things we can control, these future conditions, and others are a little bit harder to control. And so by immersing yourself in this world, the idea is to be able to give people, you know, residents, community members, an idea of what some of their decisions today might lead to in the future. Any questions?
Would your research be used for something that people would have to go off of, like for wetland protection, just environment protection in certain scenarios that, like, the Corps of Engineers would be like, this is what we have seen, this is what researchers have seen for this specific area of this watershed that's here. Would your research be used in that in future cases where, like, if we do this here, this is going to be the impact we will see 50 years from now?
Yeah, so the question for the online folks is, you know, is this sort of visualization, can it be used to inform decisions at agencies like the Corps of Engineering and Fish and Wildlife? And I would say, you know, a lot of those decisions are going to be made sort of from the raw data as much as possible, and other models and simulation. I would view this as a tool to basically take those existing models and put them into this virtual environment to help make real what some of these possible changes are going to be. So I think that this kind of visualization can certainly help with decision making. Certainly, I wouldn't call it a primary tool, but more of a secondary way to visualize. Yeah, I mean, you know, everything you're seeing in here is based off of a lot of research already, and so it's based on existing data, existing research, you know, different possible climate scenarios, oceanic conditions, that sort of thing. So a lot of hard research going into there, and then taking the output from that and visualizing it in this virtual world to help people understand, oh, okay, this is what might happen, and just making it a little bit more real. You're welcome. All right, so enough talk. Who's ready to do it first? Okay. So for the online folks, oh yeah, you are seeing us. Great. So let's go ahead and sit down in the swivel chair, because you'll need to be swiveling around a little bit. So we've got our 2 sensors that are picking up your head motion here, and there's infrared beams coming and detecting this on the HTC Vive. And so let's see, let me go ahead and start it up for you here. And sometimes the camera position is a little bit off. All right, yeah, for some reason it's a little bit low. So I wonder if I can, I think I need to reset. Let's just go with it. So you've got that, and then here's the controller. It's going to be your left thumb to drive, and so I think turn to your right. Okay, there's the handlebars, And if it's a little low, if it feels low for you, you can stand up. Yeah. So it's a little bit low right now. So if you just stand up, that should fix it if you feel comfortable. Oh, you're standing on the cord, I think. All right, hold on. Where's the cord here? All right. All right. There we go. Okay. You can stand up. All right. So don't fall over.
Okay.
And your left thumb.
Nothing's happening.
Move your left thumb.
Oh, sorry.
Yep. All right. And then stop here.
Life in the Kenai has changed a lot over the last 30 years. Water temperature has been steadily rising, resulting in a decline in salmon productivity, and sockeye returns have dropped to an average of 1 million. Drive down the road towards the factory to find signpost 2.
Oh, here, I should put the microphone over by the speakers here. Yeah, for now, just stick to the script and stay on the road, but then we can have fun later driving all over the place.
Signpost 2. The population has significantly increased in the city of Kenai, mostly from people who came from out of state looking for work at the new factory and oil rigs. It's up to the locals, who grow fewer and fewer every year, to carry on the Alaskan spirit of sustenance, fishing, and hunting. Sadly, as the industrial activities grow more and more, the Alaskan wilderness seems smaller and smaller. The noise and pollution emissions from the factories push the nature further away from the city every year. Drive to the factory to find signpost 3.
There are a few spots where you can get stuck on here, so it's okay if you get stuck. We can restart it, but keep that in mind.
Signpost 3. The Nikiski Liquid Natural Gas (LNG) facility was developed in 2020. It has significantly changed the Kenai economy. After the initial population and economic boom from the facility construction, more oil wells were developed in the Cook Inlet from 2020 to 2030. Because of all the industrial development, Kenai has lost much of its appeal to tourists who used to come to experience the Alaskan wilderness. Drive towards Cook Inlet to find signpost 4.
Let's switch up to another user and make sure everybody can have a chance here. How do you feel? A little motion sick? No? All right, you feeling good? You ready to drive? You bring your driver's license? All right, I think standing is better if you feel comfortable standing. It should work with your glasses. Does it feel okay? Okay, and then don't stand on that. Okay, and then go ahead. Here's that, and left thumb is gonna drive for you. And then you want to find that next signpost. Oh, to the left is the big exclamation point in the sky. Oh, other left. So if you drive over there off road, you get to drive off road. If there's time, we'll put you back in. All right, and then just stop right there.
Oil rigs, Cook Inlet is no longer considered a scenic view to many people. Once you could look out, and depending on the season, you could see an endless horizon or a bustle of boats filled with fishermen eager to catch the biggest and best fish. Nowadays, fishing is rare as severe limits are put on salmon harvests. Drive along the beach to find signpost 5.
It's okay to drive on water too. Yeah, you can't hit trees. Some assets. Oh my goodness, that was scary. That was really scary. Sorry, you should have been sitting down for that. Are you stuck? Yes. Okay. So, like I said, this is beta. So sometimes you get stuck, and the only way to reset is to reset. Okay. So you can skip ahead, I think, if you want to drive right to.
Signpost 1, year 2050. Life in the
You
Kenai
can drive to the
has
left.
changed a lot
Drive
over the
towards
last 30
the
years.
ocean.
Water temperature has been steadily rising, resulting in a decline in salmon productivity. Sockeye returns have dropped to
I thought you said you had your license. with you. There we go. So yeah.
No, never.
Okay, are you ready to go down again? Okay.
Oh,
Okay. Don't, all right, try not to get stuck. Carry some speed. There we go. Yeah. So now you turn into a boat, and if you want to hit the next signpost, it's actually behind you. If you want to turn around. Yeah, I would probably drive forward. Yeah. Oh, there. I see what you're doing. A 3-point turn. Good. Good K turn. And then, yeah, so keep going. Stay in the water, I think, will be a smoother driving experience for you. Yeah, yep. So don't run over the dip netters. Right. And then there's that exclamation point. You can drive up and to the right. Yeah, straight ahead there to the right. Yeah, you can go. All right. And so this is signpost number 5.
Signpost 5. The only sport fishing that occurs in the Kenai watershed now is from residents who live along the river. Anglers have had to switch to targeting new species as most salmon are off limits. Congratulations! You've finished the formal tour of what the Kenai area might look like in 2050 if an industrial boom were to take place.
Yeah. Okay. Okay. There you go.
Actually done. This is my first time doing virtual reality.
Okay. I hope it's a good experience for you. Okay. Just don't move your feet. Can I have the steering wheel? There you go. Left thumb. And there is a bear out there, although it's broken right now, but you can try to find it. Yeah. The bear, when it works, stands up and growls at you, and it's totally terrifying because it's huge. Right now, that asset is broken. So that would be awesome.
This is supposed to be the residential area that I talked about in the first
Yep.
second sign.
Yep, exactly. This is the expanded residential area.
Population has significantly increased in the city of Kenai, mostly for people who came from out of state looking for work at the new factory and oil rigs. It's up to the locals, who grow fewer and fewer every year, to carry on the Alaskan spirit of sustenance, fishing, and hunting. Sadly, as the industrial activities grow more and more, the Alaskan wilderness seems smaller and smaller.
You can drive through buildings, but not through trees.
Drive to the factory to find signpost 3.
Now I can drive through the factory, right?
No, I think you can't go through the fence. But give it a try. Oh,
okay.
There you go. Those pesky trees.
So the collision on the trees is working.
Right, right. And actually it was,
Oh, okay.
see, I didn't think you could drive through that. And, of course, you can add colliders to all these assets, but every time you add a collider, you increase the computational
the
load, right? Because as it's driving, it has to say, hey, am I near this asset? Oh, am I near this asset?
See if I can. There we go.
And it is possible to get stuck. Oh, you're not stuck yet, though. There we go. Yeah. So I have a tough time with this. After a couple minutes, I start to feel queasy and off. So.
I'm just trying to keep it adjusted so I can see.
In most games, you print the left thing, so that's why I'm using that.
Oh, there's one. Okay, so the collision is okay. That's good to know.
Yep, collision is on for that.
All right. Now, are those just background, as in they're not actual?
No, they're there. Yeah, you can drive out to them. There are assets out there. Yep.
So the water is. Are we still live?
Yes, we're still live.
Okay, excellent.
We're gonna turn
You're
off
good?
the mic.
All right, all right. Bye bye, everybody. For at least, well,
For now.
For now.
Yeah. For a minute or two. Hello, hello, hello.
Oh, you got to be kidding me.
You have to pass the baton when you talk.
Oh,
That's how that works.
this makes me nervous every time.
We're being recorded for this one, so like, we can't have privacy.
I got it. All right, so hopefully they can hear me. If not, I don't know what to tell them. So we're the Computer Science Club. You met me downstairs already. I'm the president. These are some other members of the Computer Science Club. So I will let them introduce themselves. I guess I'll pass.
I'm Lincoln.
Deanna.
I'm also Eli.
Eli's a very uncommon name. However, in the Computer Science Club at UAA, it's very popular. So it's half the members. So today we're going to demonstrate a project that we've been working on. We just started this as kind of a prototype stage. However, we were not aware of this event until last Friday, so we kind of threw something together just to present to you guys. But basically what this is going to do is there's an infrared reflector here, and this Connect is sending out infrared light, and the camera's looking for that to determine where it is. And then if you can see here, it will kind of, yeah, here, I want you demo it while I talk about it. So it's gonna track where she's moving. And basically what we can do with that is if she does these certain gestures here, which you can kind of see on the board. So why don't you do, yeah, the infinity sign. We'll do a light toggle, and you can see right here it prompted a light toggle. And so this right here is called a computer terminal or command line. It's basically the most basic way you can interact with a computer. So you can give it commands, it'll relieve or give you back commands. And so what it's doing is it's just giving out text, blinds toggle, for example.
So it's like a house.
Yeah, so that's what I was kind of getting at. So this right now, all it's doing is printing text, but you could imagine that the code that's making it print this text could just as easily turn on a light bulb, for example, or lift blinds. Yeah, and you can definitely more than welcome to try.
You gotta stand about here. Yeah, there you go.
How many of you guys are considering a CS degree?
Oh, you might need to test the mic.
Oh,
I don't know how the mic's.
Yeah.
Yeah. Okay. So that's you're going to be basically teaching a program as a computer scientist or the computer science program with a few additional classes. Well, a few different classes.
So we're gonna work on like engineering degree and then go back and finish the science classes after that. Hi. Hello.
So I don't know if this is true inversely, but for the computer science, for example, I'm a computer science major.
Yes.
I by default get a minor in computer systems engineering, and I think it's the other way around too. So if you get a computer systems engineering degree, you will automatically get a minor in computer science. So that's not true at every university, but UAA has a lot of engineering classes in its computer science program.
Also, to major in computer science, to get a double major in computer science also. Or to get a major in computer science also, you only need to take 2 or 3 additional classes if you do a CSCE. Yeah. Yep.
Much out of the education
and then like
This mic situation is horrible. I absolutely hate microphones. Yeah, that's true. I just totally lost my train of thought. You just give us all.
It's okay.
yeah, so like with like where you have like multiple things, like if you do computer systems engineering, I think it's only like 2 more classes to also get a math minor as well.
Oh, it's one.
One?
One. Because you literally have to
Yeah,
take
not computer science.
Yeah, to get a math minor, if you're a CSE, you already have to take Calc 1, Calc 2, Calc 3, and ODE or differential equations. So you literally only have to take one other upper division computer or math course. So for CS, I had to take 3 others. So Calc 3, and then 2 upper division. So again, it's really close in a lot of these to get minors and this stuff. So it's really easy.
So for me personally, I'm in the situation where I haven't done any math courses since 2008, 2009. So yeah, I like the last class I took was algebra 2. So
I did, and this isn't required, but I would strongly recommend it. Is I took it's pre-calc, but you could also just take college algebra just as like a refreshment because I hadn't taken math in 4 years or something when I got here. And then from there on, just take all your math classes every semester. So don't like take breaks because you'll forget stuff.
Right now I'm doing Right now I'm doing Khan Academy. I'll hold it. And I have to start all the way back at pre-algebra because I tried going through algebra 1 with Khan Academy and I forgot everything and I'm like, okay, I have to go back a step. Yeah, because you have somebody who's like directing who's like, this is where we're going to start, this is what you need to remember, this is what you're going to be doing. Where at Khan Academy you don't have that. You have to start from like, okay. Yeah, and that's kind of where I'm at right now, is because I want to get to the level where after I've done my Alex 1 and then take the Alex again to get a proper placement, I want to be able to choose like just go straight into calculus. So
Yeah, and then like so like you said, like with this also sort of goes into like tutoring stuff. Like there's tutoring available. Like for math, there's the math lab. Like I've never seen 2 math labs. I didn't even know there was another one.
Worst thing is the professors for math. They're still here because they do their own research here. Yeah, and so you could always go in and ask them for help if they're on site. Their classrooms are in the SSB by the library. They're over there. I mean, they're generally willing to help people with math whenever. Yeah.
He'll show up.
No, it's good.
So I was going to go back to this. So kind of where we got the inspiration from. So if you actually go to Universal Studios in California to the Harry Potter world, you can buy this infrared reflector wand and go to different parts of the park and wave your wand around and it will trigger certain items. So someone else who kind of did like a good chunk of this code. So we're using some of this code to pretty much base it off of, and we're expanding it. Was basing off that idea, but why not do it at home? So that's why we use the Xbox Connect and then the our Harry Potter wand to do the same thing. So we do plan in the future to do more stuff with this. So again, right now you can see if you do certain shapes, it can track for a good extent what spell you're doing. And so one thing, instead of just printing to the screen like Elijah, or the terminal like Elijah was saying, you could easily transfer this to like with the light toggle, actually turning on a light bulb. So one thing that we might do with the music toggle, music starts playing like Hedwig's theme, let's go, Harry Potter, something along those lines occurs depending on the action which you see on the screen, which this is, in general, this is a really cool computer science problem because it uses the ideas of data science and like machine learning. So I guess, do you guys understand what data science is? So we have a really good example. Do you want to explain it?
All right. I imagine you have not asked your parents for money in the last like recent amount of time. Same boat. But so think about every time in the last 2 years that you've asked your parents for money. Think about what time it was and whether or not you had done your chores. It sounds silly, but if you think back and you look for the trend of when they said yes and try to correlate all those, what time it was, whether or not you've done your chores, that's going to give you a potential probability of whether or not they will say yes if you do the same actions. And that's essentially data science. In
But yeah, so the cool thing, we use kind of the ideas of data science and machine learning to pretty much figure out what the heck the wand pattern is, given the fact that everyone can draw an infinity sign differently. It can look like an hourglass. It can look like an open 8. It could be non-connected and it would still recognize it as, oh, look, it's an infinity sign. So that requires a lot of training and a lot of taking the data and being like, well, that looks like an infinity sign, so I'm going to say that is an infinity sign. Let's go. And then it transfers that stuff. So we are training, or the data itself was trained. So some model was trained to say, if I see something that looks like an infinity sign, say it is an infinity sign, and that means it's a light toggle. If I see a circle or something that looks like a circle and it doesn't have a second circle, it's most likely a blinds. So recognize it as a blind. So all of this is a really interesting problem in general, and only like a very, very small portion of what computer science is in general. So I guess, do you guys know of any other like sub type fields that computer science might cover?
Networking.
Yeah.
Network security is.
Yes, network security is a big one. And one of the bigger up and coming jobs.
Video games.
Video games, of course. Yep. So game design and
but the stock market.
yeah, you could actually very much, yes. You can train
Something like 99% of, I think. So something like 99%.
Yeah.
High frequency trading. So that's the idea that there's software that's trading
No, that's even weirder.
But that's all programmed. I mean, there's no way a human can trade that fast. So it's all automated.
That's one thing. Just thought that was like stock market most likely.
So that's another thing that I was going to say with because so sometimes it's hard to think of like, oh yeah, what is a computer science, like what would you do with a degree in computer science? And the answer is like literally everything, because I mean, I think you'd be very hard pressed to find an industry that doesn't use computers in some aspect of its business. I mean, even if it comes down to farming, there's GPS tracked farming equipment that's automated, right? There's, do you like race cars is the example I keep using over and over again today. For some reason, racing must be on my mind. But if you were, yeah, if you, Exactly. Exactly. And that's just like very, very small, minute examples, but that's basically every industry on the planet right now uses computers in some way. So you don't have to get into computer science and think, oh, I don't want to be some like nerd that just like sits behind a computer and like has a boring job. Like you could do anything you want with a degree in computer science.
Yeah, actually, when I was looking for internships, what company I found that did a machine learning type internship? The Walt Disney Company. Yeah, the Walt Disney Company does stuff in CS constantly. And I mean, they do multiple parts and subsections of CS. So machine learning, they do computer graphics, web design, app development. There's so many parts of CS. And again, it's not just having CS under your belt is so advantageous. I mean, even just one programming language is a great thing to put on a resume. It's a great technical skill that shows I can use a computer. Yay.
And I think one of the things that I think is the at least biggest for me is the fact that as a software developer, more often than not, you have the ability to work from anywhere. I work on a software development team, and two of our developers work remotely. So one lives in Hawaii and Orlando, and he just goes back and forth willy-nilly. And the other one lives in Texas, and they both make $130,000 a year and hang out and go where they want to.
My sister has friends that do that, and they're traveling all over the place. Like I think they went to Australia recently, and then they're gonna go to like somewhere Asian. I don't know.
Any last questions, or we're pretty much done. So you can do like one final question. You can always just ask it, but we're not gonna. Any questions?